ladies and gentlemen, so what we're going to be doing now is we're going to be taking these equations that we have and we're going to be able to now write them two different ways. The way that we have been writing them, right, our y equals mx plus b, is what is called an explicit formula. An explicit formula, we're done here, we're going to be jumping all over today, so I apologize. So an explicit formula lets you know, like you can tell any point on the line or a term of sequence directly and you substitute in and you know what you're going to get. Right? It's kind of like a function rule. You put it in, you know what it's going to get. We're going to now also be able to take these and we're going to be able to write them using what's called a recursive formula. And a recursive formula, instead of being like, okay, I know I can plug any number in and do it, you have to know a couple things. And our general format is that we're looking for what's coming next. And in order to do that, we have to know, well, it's what we have now plus some value. But in order to do this, you have to know where it starts. So starting at. All right, well, what does that mean? So recursion is the process of choosing a starting value and repeatedly applying the same process to arrive at the following term, whether you're adding or you're subtracting. So if I were to start at 5 and I want to keep adding 2, so it would be 5, 7, 9, 11, and so on. A recursive formula has two parts to it. It gives you the starting point and the pattern. So you have to know those two things. So we're going to kind of put down here that there's two parts. Two parts to a recursive. Explicit, there's only the equation. That's it. All right, so let's talk about this. So we have here, Hank is paid a monthly salary of $800 and a commission of $2 for every item he sells, right? That's kind of like our per. Express Hank's monthly income as a function of the number of items he sells. So normally, right, if I'm not even talking about this, if I just said, write an equation for this, well, y, right, this is your slope, 2x, plus the salary, plus 800. Right, that's what we were working on before. We modeled it. It was good. All right, well, in this one, now I need to know, right, if I'm going to do a recursive, I need next equals now plus question mark starting where? Well, they have some specific notations. The now is always called A of n. It's just telling you that it's a given value in a big list. Next is going to be A n plus 1. Starting value is called A1. And we'll talk about those in a second here. So this part does not change. This does not change for our formulas. So I'm going to write, so I need next equals now plus a question mark. So an plus 1 equals an plus, I need to know this right here is how much is it changing by. Yikes, ran out of room. Well, it's changing by $2, right? Every time he sells another item, it's going to go up $2. I also have to name the starting point. The starting point is A1. Well, he starts with $800 no matter what. If he doesn't sell anything, he still starts at $800. So you'll see these two parts from our explicit match up over here. Our B, our y-intercept, is the starting point. Our slope is the how much it's changing by. So we should be able to go from one to another. All right, so let's see if we can try this in another example here. In 1904, a dictionary cost 30 cents. Since then, the cost of a dictionary has risen an average of 6 cents per year. Right? So right here, this is your starting point. Starting. We call that usually B. It would also be called A1. All right. Since then, the cost of the dictionary has risen an average of 6 cents per year. 6 cents, by the way, is written as 0.6. This is your slope. Right? That's how much it's changing. So if I want to write it, the cost this is y, after y years, right? Which I actually don't like y years, I like t for time. But anyway, those are your x values. So if I were to do this, right, cost equals, well, if I were to write it normally, it's 0.06. I can't use y there. I'm going to use x. Sorry. Plus 0.30. 30 cents would be 0.30. There's your explicit. Your recursive, right? I'm going to write it out. I need next equals now plus something, and then I have to say, excuse me, starting at what? All right, well, this part's always going to be the same. A(n plus 1 equals a(n). This is how much it's changing by. This is going to be your slope. It's changing by 6 cents. It's starting at 30 cents. So every time I'm going to keep adding 6 cents onto 30 cents. All right, next one. So Maxine is doing a 5,000 piece puzzle that has zero to do right now with what we're going to be looking at. She already placed, that's your beginning, that's your starting, with 175 pieces. Every minute she places 10 more pieces. That's how much it's changing. Right? This is your slope. Starting is your b. So if I had to write this as a function, so this is going to be your explicit, because it says it wants explicit and recursive. Right? So my general form, y equals mx plus b, fill everything in. We're going to have 10x plus 175. For my recursive, I need, right, we need it's next equals now plus question mark starting at whatever. Okay, so next, an plus 1. Now, an. How much is it changing by? It's changing by 10 pieces. Where is it starting? A1 is 175 pieces. Okay. Biologists estimate that the number of deer in Rhode Island in 2003 was 1,028, and in 2008 it had grown to 1,488. Biologists would like to model their deer population, P, as a function of the years since 2000. So 2003 is going to be 3 years since 2000. 2008 would be there. Model the situation. Well, I don't have, it doesn't tell me what it's changing by. So I have to first, I'm going to write these as points from the graph. So my first point would be 3 and 1,028. And the second point would be 8 and 1,488. Right? Because I need the slope. Well, I'm going to use my technology and I'm going to put these into my calculator. And I'm going to put these into list 1, and I'm going to put these in list 2, and I'm going to do my linear regression. When I do that, again, I can show you the way that it's going to take a lot more work, but y equals mx plus b. In your calculator, it's going to say a, but this is 92x plus 752. Now remember, this is how much it's changing. And then this is the starting. So there's my explicit formula. This is the explicit. And I did that on the calculator. I didn't do anything fancy. I put it in the calculator. Now, to model it recursively, sorry, we need next plus now, or next equals now plus question mark. And we need starting. Well, next is an plus 1. Now is an. I need how much it's changing by. Changing is your slope, plus 92. Starting, A1, is where does it start? 752. And we'll demonstrate in class a little bit more about how these work, and we're going to do all kinds of different things with them. But hopefully you're seeing how these are related to each other. Your slope becomes your change. Where you start becomes your A1. Okay, any questions, which I'm guessing there will be, bring them to class. Otherwise, have a good night.